Hello everyone, and welcome to this example recording on the step response of an RC circuit. So the question we're going to look at reads as follows. For the circuit below, find Vx for t greater than 0, and Vx would be your response over your capacitor. Usually it would be indicated in a diagram. And the second part of the question also wants you to determine Ix. So we're going to also look at Ix. Alright, so what type of response do we have? We can see that when t is smaller than 0, we've got a source connected, which will initially charge the capacitor. But when t is greater than 0, the switch shifts from this position, let's call this position A, and let's call this position B. It switches from position A to position B such that you still have a source connected to the capacitor. So we know that this will be a step response, and a step response has Vt equals V infinity plus V0 minus V infinity e to the negative t over tau. So voltage at time t is equals to infinity, voltage at time t is equals to 0, and tau is what we need to determine. So let's start off by t is equals to 0 negative. We know that the circuit should look as follows. The capacitor will become an open circuit, and we're looking for the voltage Vx or Vo, which should be the voltage over the 5 ohm resistor. So we have 30 volts dropping over the 3 ohm, the 10 ohm, and the 5 ohm, and this part of the circuit won't be present. So Vx must then give us 5 over 5 plus 10 plus 3, all multiplied by 30. So that's 5 over 5 plus 10 plus 3 multiplied by 30, and that gives us a value of 8.33 volts. Therefore the initial voltage is 8.33 volts. What about the final voltage? The final voltage we know will consist of the following. So we will still have the 5 ohm resistor, we're going to have the 10 ohm resistor, the 3 ohm will fall away, and we're going to have the 7 ohm resistor, and now a 15 volt source, and we're still going to have plus minus Vx that sits at that point. This is at time t now is equals to infinity. Right, and we will be looking for Vx, which again is going to give us 5 over 5 plus 10 plus 7 this time, multiplied by 15. So that will be 5 over 5 plus 10 plus 7 multiplied by 15. And this will give us a value of 3.409 volts. Right, next we need to determine the time constant, which is equals to Rc. We know that C is the equivalent capacitance that would have been given, which is 5 farads. What about R, which is RTh? we know that this must be at time t greater than 0, which would be in this scenario. So in this scenario, we know that the that voltage source will become a short circuit. Gonna have your 7 ohms, your 10 ohms, your capacitor reference point, and your 5 ohms. So that's 5, that's 10, and that's 7. So RTH must give us 10 plus 7 in parallel with 5. So that will be 17 in parallel with 5. And that should give us a final answer of 3.86 ohms. So RTH gives us 3.86 ohms. Now we can get the time constant, which is going to give us 5 multiplied by 3.86, and that should give us a value of 19.31 seconds. And finally, we can say VT is going to give you the voltage at time t is equals to infinity, which is the 3.409 plus the initial voltage 8.33 minus 3.409 e to the negative t over 19.31, and that's going to give us 3.409 plus 8.33 minus 3.409 gives us a value of 4.92. E to the negative t over 19.31 volts. Right, and the final part of this question was to determine the current. So we've got the voltage. We know that the current IC must be C dV dt, which is going to be 5 d dt of 3.409 plus 4.92 e to the negative t over 19.31, and this is going to give us 5 times the derivative of a constant is 0. The derivative of that expression is going to be 4.92 multiplied by negative 1 over 19.31 e to the negative t. And that's going to give us a final answer of minus 1.27 e to the negative t over 19.31. And that will be in amps. And this is the current as a function of time. Thank you for watching this video and enjoy the course.